Hello and welcome to the eBPF and Cilium Office Hours live stream. This is episode 36, I believe. As always, welcome to all our live viewers. Do drop in the chat to let us know that you're here, that you're watching. Tell us where you are in the world. It's always great to hear from you. And today I'm going to be joined later on by a new colleague, Kevin Sheldrake. He's going to be talking to us about his previous project, Sysmon for Linux. But before we get to that, let's have a look at some of the interesting things and headlines and articles that have been written in the last week or so. So I've got a few items under the headlines today. Before we do that, I'm going to say hello to Quentin, who helped us assemble a lot of the news, as always. So welcome to Quentin. First item under our headlines today is a talk at DevConf. I don't know how you pronounce this, devconf.cz, I guess it's Czechia. And it looks like the conference has a whole bunch of really interesting talks, but this particular one about eBPF is worth checking out. It's covering a lot of new features that are coming in the pipeline by Jerzy Olsa. I hope I've pronounced his name correctly. As always, you can find the show notes in HackMD. I think it's that side on the screen, the link to our HackMD site where you can click to find all the links. We also, after the show, put all the show notes into our GitHub repo. The next article on my list is by our friend Jalal. This is one about blocking fileless execution using BPF LSM, so Linux Security Module Interface, running BPF programs attached to that. So that's a really interesting security-focused article, definitely worth checking out. I think he also has another BPF post that he linked to just before the show that he sent me. So I'm going to check that one out for next time. So thank you, Jalal, for bringing that to the show. Just going to say hi to Russell, regular viewer. Nice to see you. Okay, the next article that I have on the list is by Leonardo, who's pretty well known, I think, in the eBPF community. And he has been working on producing code coverage for eBPF programs. So this article that he's written for Elastic is showing all the background. He's showing us how he's implemented the code coverage. And I think if I scroll all the way down to the end, we can find that he has actually achieved what he set out to do. So we can see, for example, indication of what lines have or haven't been covered. Yeah, probably that's a good example. So that could be really useful if you're writing BPF code yourself and you want to see whether or not you've actually exercised all your code. So well done to Leo for that. And the next article is in the New Stack. This is really a post about the state of play of eBPF for Windows. So Mary Branscombe's spoken to some folks at Microsoft and other folks about why Microsoft are bringing eBPF to the Windows operating system. I think Kev may have some points that he can share with us about that later, since he's joining us from Microsoft. And the final article that I've got here is about using network policy to improve your Kubernetes security. So this is a really nice post that Piotr has submitted. Now, he let us know about that through the eBPF news channel on the eBPF and Cilium Slack. So if you've been writing interesting posts about Cilium or about eBPF, do reach out and let us know. Really good comment here from YMO. He says, or he or she, they say they've joined from Canada and that code coverage via eBPF is amazing. Yeah, definitely worth checking that one out. So thank you for that. Okay, so as always, let us know if you have ideas for things that you'd like us to cover in the show, project that you've been working on. We're always interested to hear about them. All right, so I think it is time to introduce my guest for today, Kevin Sheldrake. Welcome to eCHO. Thanks for joining us today.
Hello. Thanks for having me.
So Kev, as I mentioned, used to work at Microsoft, and we're going to talk about some of the work he was doing there on Sysmon for Linux. He's recently joined the Isovalent team, and I guess one of the interesting things, when you get to know a new colleague is you find out a bit about their hobbies and pastimes. And Kev actually does loads of really interesting things involving magic and hypnosis. I hope we've got a link in the show notes. There was a really good video that he shared with the team of a magic trick involving a light box. I don't know. Maybe by the end of the show, we can get him to reveal the secrets to how he did that, because it's pretty impressive. I've got to say, I really like that one. So well done.
I mean, as a member of the Magic Circle, we are forbidden from revealing those secrets, unfortunately. So you'll just have to be amazed and wonder how it might work. But yes, it's in the show notes. There's a link to that. Basically, I'd been at one of the magic conventions and saw something like this many years ago, and something reminded me of it during lockdown, and I decided to find out how it worked and then make my own. So that's something I constructed. I also made a fantastic bookshelf door during the lockdown as well. So the access to our spare bedroom for when guests come to stay is through a bookshelf, and there's a link to the video for that. So it's the sort of random things I get up to.
Really, really great question from Russell. Does that lightbox use eBPF?
No, there is no Linux in the lightbox. Or Windows for that matter.
Well, no operating systems were harmed in the production of this magic trick.
It's exactly. But yeah, it's worth having a look. But I mean, the stuff I do more of is hypnosis. I'm currently studying for a master's degree in psychological methods as an entry to a PhD in hypnosis with my hypnosis hero, Professor Zoltan Dienes, who's probably the UK's leading active hypnosis and suggestion researcher. So so that's a lot of fun. So as part of that, I write a blog with my wife called Cosmic Pancakes, which is also
I've got a little screenshot of that actually. Yeah, there we go.
Exactly, where we discover the weird and wonderful world of hypnosis. We review a lot of vintage books. I review some academic books. I interview some academics on there. Amy interviews some professional kind of performers, and we just kind of enjoy that whole world. It's a mad place. So yeah, have a read, but be warned, I have to put in the warning, there is some swearing and some adult themes on that website, so be aware.
Good warning. And Russell said, so real magic then, not just Linux magic. Very good.
Oh yes, of course.
All right. And I just want to say hi to Walid and to Dorben Dov, who have also joined us today. Nice to have you with us. All right. So, Kev, tell us a little bit about your life before Isovalent. You were working on Sysmon for Linux, and that was built using eBPF, right? So maybe just tell us a bit about how you kind of came into eBPF in the first place.
Yeah. So my professional career has all been in computer security in one form or other. So I was making secure systems at one outfit. I became a consultant advising people how to make secure systems. Then I became a hacker, hacking into supposedly secure systems to help secure them. I've hacked devices, I've broken cryptography, I've attacked RFID and radio. You can find some talks of mine out there on the internet. But the job I did before I came to Isovalent was at Microsoft, and I joined the Microsoft Threat Intelligence Center. and which is a small team sort of based out of Cheltenham, although they do have other people, in the States remotely. But as a team, we generally made the technology that allowed detections to be created to spot attackers. So, other parts of Microsoft secure things, stop attackers getting in. And the job of the Threat Intelligence Center was, if attackers have got past those defenses, how would we know? And how would we spot them? And so there's two parts to that. There's telemetry generation, which is kind of observing systems and creating events and sending them into a big database. And then there's detection sort of code or whatever, which takes the big database in near real time and historically, and combs through it, joining events together to say this looks like an attack, or this looks like some sort of malicious action. And their agent for one of the projects that we supported, a number of projects. One of the projects we supported had an agent which was running on K-Audit and or Audit D, depending on whether you had Audit D installed or not. But it's built around the K-Audit kind of subsystem, which, most telemetry on Linux, most auditing was built on K-Audit or Audit D before eBPF, in fairness. But it has its drawbacks. It's not very configurable. The more rules you add, the slower it becomes, because it goes through the rules sequentially in a kind of like linked list kind of way. It's not very smart in that kind of thing. You only get the data that it gives you, so you can tell it what you want, but it's limited on what data it can hand you. So while working on that agent to try and generate better telemetry, had the idea of looking at eBPF because that was a new kid on the block at the time, and built a proof of concept which kind of mimicked Audit D to some degree, but entirely written in eBPF. And there's a link in the show notes, so people can go and see that early work. Bear in mind, it was very early work, so don't judge me on.
Everybody feels like that about their passcode. Everybody.
Exactly. So in tandem to what was going on at the time, Sysinternals, who support something like 70 or more tools, and they had their 25th anniversary last year. That's how long Sysinternals has been going, which is a wholly owned sort of part of Microsoft these days. They had released.
Was it previously external to Microsoft, or?
Yes. So there's if you, so I literally got an email yesterday to say the Sysinternals at 25 videos were going onto YouTube. So I don't know if they're on there yet, but they will be available individually. But there's also a live, you can rewatch this entire 6-hour live stream. But Mark Rasunovich talks about the start. So there was Sysinternals, which made freeware but closed source tools, which helped you administer or monitor your Windows systems. And then separately to that, he also had a company called WinInternals, I believe, which was his consulting sort of professional side. So one kind of supported the other, if you like. And Microsoft acquired, I think, WinInternals and got Sysinternals as part of the deal. So
I won't get one free.
Kind of thing, something like that. But Mark would obviously correct me on all of this, and so apologies to Mark if he's watching, or if he watches this later.
Mark had tweeted at some point about how Sysmon for Linux was going to use eBPF, and I remember seeing that tweet when it happened. So where were you in the process of building Sysmon for Linux when he made that tweet?
So I was still working in Mystic, the Microsoft Threat Intelligence Center, building my proof of concept, or I built my proof of concept, which was an Audit D type thing. They had released Procmon for Linux, which was based on eBPF using BCC, which lets you monitor syscalls, for example, across the system, per process, etc. And I'd done a hackathon a year before. With one of the Sysinternals engineers to kind of prototype something, but we weren't using eBPF at that point. So We saw that tweet and thought, does he mean the stuff I'm working on, or are they doing it themselves? Like we didn't really know much about them. I mean, Mystic and sysinternals have a close relationship. So when Sysmon was originally written for Windows, it was Mystic going to Mark Rustinovich and saying, hey, with all of your knowledge and all of your tools, can you make something to monitor Windows, and can you make it quickly? Because we have a active case where we could use a tool to do that, which would, to augment what's already available in Windows. So he and some of the Mystic people put Sysmon together. So there's quite and then over the years they've contributed a lot of code to it. So there's quite a good link there. But no, so we went to Mark and presented my prototype, and he was like, "That's brilliant. Do that. Make Sysmon out of that, please." So I spent a number of months looking through their code. He said, "I want it to be open source, and I want it to share as much code with the Windows version of Sysmon as possible." So, Sysmon's got 8 years of development in its configuration engine and its rules and filtering. And one of the things that makes Sysmon so great is the advanced filtering. You can be very granular about what kind of events you do or don't want. And he didn't want that reinventing. He didn't want something that looked like Sysmon but was a separate project. He wanted it welded together as sharing code. Which is obviously an interesting thing to do, to write an open source tool that shares code with a closed source product.
Yeah.
So, I did ask him, like, well, do you want to open source? Have you got plans of open sourcing the Windows version? And he says, no, absolutely not. And I was like, okay. Do you want to make the Linux one closed source? Because we've got things like Holy Build Box and other delivery mechanisms. We could make binaries. And he was like, no, I absolutely want that to be open source. And I was like, but you want it to share code? And he was like, absolutely want it to share code. So, yeah, I then kind of joined them on kind of secondment. I worked full time for sysinternals while still technically working for Mystic. To bring that to life, which involved porting a whole load of code from Windows to Linux, or to POSIX, technically. That became the Sysmon common repository on GitHub. And then I re-implemented what was a Windows driver in Sysmon, which collected the events in eBPF. And together, I also kind of abstracted out as much of the eBPF side of things as I could into a library. So, which also there's also a licensing implication for why we wanted to do it that way, but also so that we could reuse that library in, for example, Procmon. I don't know where they've got to, but when I left, there was a good push to move Procmon for Linux onto the sysinternals eBPF library that I'd made, to give it to release it from that BCC kind of dependency,
Right.
Because you don't always want to have Clang and LLVM on your production servers. You just want to install a tool and run it. You don't.
Yeah. I mean, I think BCC was a really good tool at the time for making eBPF kind of as portable as it could be, by saying, well, you have to ship all of your build tool chain as well. But if you've got the build tool chain, then you can build and run your BPF program anywhere. But presumably, what you've used in that BPF library, is that more like libbpf, or?
Yes, exactly. The idea of, so I really liked the idea of core, compile once and run everywhere. But I was a bit limited by core. So another of our requirements, which I might have invented myself, in fairness, it might have been my own my own idea, but it was, we couldn't rely, or we couldn't expect customers to recompile their kernel to add BTF, the BPF type format.
And they might have been using old enough kernels that didn't have it already.
Exactly. They don't necessarily want to install a symbols package. It was kind of like BTF for older machines had quite was a bit of a dependency, in fairness. So, but we really wanted to be able to reach into the kernel, with the things that it was interesting that talk at DEF CON came out, which was showing the Phantom attacks. It was really worth seeing if anyone hasn't seen that.
We'll add a link to that in the show notes if it's not already there.
That's
it's really good talk.
That's a great idea. So it's a time of check time of use vulnerability, where if your program you're monitoring is passing a buffer to the kernel to a syscall, like open at, and you pass a path name in a buffer, then the time at which eBPF sees the parameter to the syscall is different, obviously, to the time at which the kernel sees the parameter and actually acts upon it. And because you own that, or the program owns that buffer in userland, the program could change it between the two times. I mean, obviously, the timing is tricky to get right. There's all sorts of caveats to it, but theoretically, that's something that could be done. So what you end up monitoring and logging isn't necessarily what was passed to the or acted upon by the syscall.
Yeah, and I think we've seen quite a few. I mean, as that DEF CON talk showed, I think a lot of eBPF tooling has taken this quite, I don't know, naive approach almost to like, well, we're just going to hook into syscalls. And I start to think it's quite important that people realize it's not just syscalls. There are plenty of other things you can hook into as well. They don't all have to be syscalls. And that, that time of check to time of use issue kind of highlighted how you really need to know what you're doing if you're going to build a security tool using eBPF, because I mean, like you say, it's not super easy to exploit that, but if you were building a security tool, you don't want to have a kind of fairly well-known way of attacking.
Absolutely. I mean, one of the things that my career has always highlighted to me is developers are great at developing and security people are great at finding security bugs, but there's not a lot of crossover between the two. I mean, there's more now, this whole, shift left and things like that. There's a lot more going on, but it's not really fair to kind of, kind of harass developers for not knowing these things. But obviously I was coming from a massive security background, so when I was building Sysmon, that was at the forefront of my mind, was you can't really rely on these buffers. And it's not just that you can't really rely on them, they don't always tell you what you want to know. So like the open at syscall being a great example, so libc no longer uses open. So the syscall where you would pass in an entire absolute path name or relative to your working directory, that's no longer really used sort of kind of anywhere. Open at is the one that gets used everywhere. So if you call open, it will become open at under the hood, and that could be open at a particular directory when you pass in a directory file descriptor. It could be at the current working directory if you pass in a special file descriptor, or it could be an absolute path. So if your BPF code just reports the parameters, then you might get a relative path and a file descriptor, and that file descriptor means very little in userland. It might be like 17, and you're like, well, what does that mean?
Something's got to map that file descriptor to a human readable name. Yeah,
exactly. And that introduces another time of check time of use vulnerability, because that file descriptor might have been reused by that point. If it's the current working directory, so there's a special one at CWD, a special file descriptor. If you're reading the current working directory in userland, then again the program might have changed that by the time you read it. So the data isn't 100% reliable. Now, obviously, with everything, nothing is going to be 100% reliable, but sysinternals prides itself on good quality code and on fixing things and making things right really quickly. So what you can't really do is take a product into the market knowing that there are obvious things wrong with it, because people will just exploit those things. So so from the early days, the idea of like, well, what file is actually being opened by open at? So we still hooked into syscalls a lot of the time, and I did have hooks into other trace points. We tried to avoid K-probes typically, mainly because trace points were much more stable. But there's thousands of trace points beyond the syscall trace points. So there's lots of other places you can hook. But we wanted to apply it to as many kernels as possible with minimum changes and minimal sort of expectations. So we kind of did focus on trace points. But even from, say, the syscall, the open@syscall trace point, you can still reach into the kernel and find the file. So if you're hooking on the exit of open@, when the kernel's done all of the work, the return value is the new file descriptor for the file you've just opened. And obviously on the way in, you could have hooked the entry to pull the mode and permissions, so whether it's a create or an open or whatever. But you can look at that file. You can pull up the task struct with a BPF helper. You can find the files struct within there. You can find the file descriptor table in there. You can then look up that file descriptor, and it will give you an inode. And from that inode, you can construct a path. And that will be the file that actually was opened and the file that's being returned to userland. So
I think I've noticed that
always
pattern
better
in quite a few of the I'm going to say BCC examples. I can't remember if it applies both in the libbpf tools ones or the kind of original set, but that idea of collecting some information as a syscall is made and then kind of filling in the remainder of the information and the kind of results at the exit, it seems like a pretty common pattern there.
Absolutely. I mean, one of the reasons you might want to do that is just to know whether the syscall passed or failed.
Yeah.
And you can only get that at the exit, obviously, but equally you can only get the parameters on the entry. So you often have to hook kind of both and then store it in between in some sort of map or whatever. So obviously to reach into the kernel, you need BTF. That's the law. That's the way it works. You need core, you need BTF. But we didn't want core, we didn't want BTF, but we still wanted the semblance of core and the semblance of BTF. So I wrote my own thing, which provides offsets to the parts of the structs that I need.
I think you spoke about that at the eBPF summit last
year.
Yes. Yeah.
Yes, I gave a very quick 10-minute whistle-stop tour of the idea. Which at the time wasn't publicly available. It was due to be launched. So I think the summit was in September, August or September, and then we launched in October. So the idea is that if you haven't overridden the function by providing a configuration file specifically for your machine, which is the normal case, you haven't done that, then the first thing it would do is look in a database that we ship with it and see if your kernel is in the database, because if you've used an off-the-shelf kernel, it's probably in there. We were provided those offsets by the project Frita, another Microsoft project. They were doing something else entirely, but they just happened to log all the offsets, all the symbols in all kernels that they could get their hands on. So I borrowed that off them, and and that gives you the access. That tells you where to find things in the kernel. So, but if your kernel's not in there, then the next thing it would do is automatically discover the offsets. So it would use BPF to dump the memory of the task struct of a known process and then go hunting for things that it knows. Right. So one of the things is the process ID and the task ID. So that's combined. That's like a 64-bit number. So the chances of finding it, by accident, finding a different entry that's got that number in is quite low. So you can take the task struct. I took something like 4K from the start of the task struct, sent it to userland. Userland searches through that, looking for that value. When it finds it, it now knows the offset to the PID, which is really useful, because if you can find the offset to the parent task struct, you can now look forward in that memory to find the PID, right? So you can get the parent's ID, which you otherwise can't get from BPF very easily. From there, you can, knowing the structure of the task struct, which you can get by looking at the kernel sources, and I use the Elixir at Bootlin all the time to compare different versions of the kernel for the same structs to see how they change over time. and then you've got all the configuration options and optionality, but you can pretty much look for certain other things. So for example, if your process has set its UID and GID to particular values, when it then goes and pulls down struct memory, you can find pointers that might be the pointer to the cred struct, dump that memory to userland, and then userland can search through that to see if it matches a cred structure, i.e. looking for those values that it's set itself, at which point you then know the pointer to the cred struct, and you also know the offsets in the cred struct to the UID and GID. So using that same approach, I basically mined, I don't know, 40, 44, something like that, offsets into different structs. And that works relatively well on Ubuntu. Less so on
passing that memory, that you're passing anything you shouldn't be, or passing any memory to user space that it would be dangerous to expose.
Well, I mean, you are root at that point, and you are running BPF programs. So, I mean, it's contained within the root owned process. It doesn't escape from there. So, and
that memory is owned by that process, or
yeah, and
right.
and then obviously gets wiped on exit. So it's not really hanging around to be attacked by anybody, hopefully. but I mean, you can't really search for it in BPF because BPF doesn't really lend itself well to that. I suppose with a later kernel with loops you probably could, but even then there's complexity issues and all sorts. It's much easier to do it in userland, or I thought it was. Maybe there's, I mean, the more you look back at things, the more you'd have done them differently, but it kind of works.
We've got a question from YMO again. Thank you. Is this something that can be pre-processed, knowing the distro and the binaries SHA-256 hashes?
Yeah. Arguably, I mean, it's all down to the kernel itself. If so, what we would do with the database version was we would just take the kernel's uname, long uname, and then look it up in our database. And if we got a match, then great, and that's pretty bulletproof as a lookup. The discovery stuff kind of is the fallback, and if discovery failed, I also provided a kernel module which did nothing. So you didn't even have to load it, but you just had to compile it against your running kernel. And then and in there it sets global variables to all the things that I care about. And then I had another program that came with it, which then mined the ELF binary of that module to pull out all of those offsets. So, and that was bulletproof as well. So you could always get it to, one way or the other, you could always get it to start up and get it to work.
That's really smart. I like that.
Yeah, I mean, it's the sort. I mean, as I say, I came from a hacking background, so the idea of pulling ELF binaries apart was something that I was quite au fait with. I've written debuggers in the past, and the like. So you get good at understanding ELF structures. So sysinternal's eBPF is the library that does those things, and then it wraps up all of the stuff that you do in every BPF piece of software, where you load in your BPF code, you go find all your file descriptors for your maps, and you set all your maps up, and then you set up attach all your programs to all the attachment points, and you set up a ring buffer, and to get events back, and all of that stuff I was doing over and over again in various different programs. So I wrapped all of that up into the library. So you can call the function of the library with a massive struct of all the things that you care about, like lists of all your programs, which kernel versions they're for, what you want attached into what, etc. And then the library will attach all those things for you. Okay. Just to, because why reinvent the wheel? It's just one of those things. Like you're copying and pasting code, you're going to make mistakes at some point, aren't you? So,
is that a little bit like what the Cilium eBPF library does in Go with its kind of
yeah,
like it generates the code to do the loading of your programs and your maps and attach them to events.
It's a similar thing, yeah. So mine was pre-compiled, so it was
Right.
it was kind of a flexible architecture that would that would connect all the right things together for you. Whereas, like you say, the Cilium one is kind of more code generation, but it's doing exactly the same kind of thing. Yeah, I was just trying to simplify it as much as I could. So, and then yeah, so then Sysmon for Linux relies on that library and uses that library, and so oh yeah, so the other thing is, the other thing the library came with was a code library of eBPF snippets, like extra helpers that I'd written myself for things that I needed, and some of those helpers were the looking up of those offsets, because just having the offset is one thing, but you may as well have some helper code that knows what to do with the offsets in order, so it could dereference pointers, it could dereference strings, it could dereference file paths from file descriptors or from inodes. And all,
Are these
all
helpers that you can call from BPF code itself, or
yeah,
or
if you've
okay, yeah,
if you, I mean, they're inline functions in a header file that you just that you include. So when you install the library /op/sysinternals eBPF has a eBPF directory in there with this code in it, and so you would hook it into your code at compile time. That's the idea. They're not built into the kernel or anything like that.
Right. Yeah.
But they're very poor man's helpers. It's extra code that gets compiled in. But
right.
You know, they were needed. But that's the other thing the library brought with it, was like some extra helpers to simplify things, make things easy. And the idea there again was reliability beyond other things. So when you write BPF code, one of the things you always come across is the verifier hates your code, like for all sorts of reasons. And it might like it on certain kernels and then hate it on other kernels, right? So and it hates it for all sorts of different reasons, like so the idea with the helpers was to write good quality helper code, test it rigorously, and be convinced that it works, and then never touch that code again. Like just just use it, but don't modify it, sort of thing.
Yeah, I've definitely had my own experiences of writing, demo code, and if I put this trace line here, it's fine, and if I put it somewhere else, it appears to be functionally equivalent to my mind, but from the verifier's point of view, for some reason, it's different.
Absolutely, it's so yeah. I mean, I documented a number of things. I mean, I won't claim to be correct, especially having joined iSurveillance, and I can see there are some absolute wizards here in eBPF. It's a really nice change. To go into a bit of a tangent, it's a really nice change. So where I was at Microsoft, I eventually joined Sysinternals full time as part of the work I did on Sysmon, which was a dream job. I cut my teeth on Sysinternals tools on Windows like PS Exec and process monitor. Process monitor. God, see how long it's been since I worked for Microsoft. Forget everything. Auto runs, etc. Right. So there's a whole load of tools that got used by hackers and pen testers quite a bit. So to get a job there and work for them, and have regular meetings with Mark, who has he still has a very hands-on approach for Sysinternals. You'll come in on a Monday and find that he's merged some code on the weekend into a tool that you're working on. He cares a lot about those tools. So that's obviously a dream job. But I was the only person writing eBPF in our part of Microsoft, and the only not quite the only person, but one of a few people working on the Linux side of things. So the opportunity of coming to a company where everyone is working in eBPF and everybody is working in Linux and everyone's working on the same kind of tools was quite an exciting thing, to expand that into a massive team rather than being the sole kind of author of a tool. was quite a nice change.
Yeah, I suspect that if we had somebody like Daniel Borkman, he would know exactly why, or possibly even Quentin would know exactly why the verifier would object to the same trace line in one place, but perfectly happy with it in another.
Absolutely. So I mean, I literally found one where it worked on one kernel and it didn't work on the next minor revision of the same kernel, and the only difference was to do with how the verifier created state points, I think they're called, for when it's working out what it believes it knows about the code. So it might have gone from like there were 10 instructions apart and then they went to 4 instructions apart or something like that. But it was literally 3 lines of code different in the verifier. And that was enough to completely reject my program for mad reasons. So
I
what you
remember reading a really nice quote I think it was an NCC group blog post, and it described the verifier as a fickle beast.
Yes, exactly. I mean, interestingly, that blog post and the talks that went with it, I was looking at right in the early days, and I know the technical director of NCC from old hacking days, and I've since been in touch with him to sort of go, there's a number of things not right about these talks and blog posts, by the way. You might want to look. One of the things they said about BPF was that that they pointed out this time of check, time of use thing, that what became the phantom attacks, and complained that was a problem with BPF. But what was the alternative? Like audit D? Well, or K audit? I mean, that suffers from exactly the same sort of thing. I built a proof of concept like that based on their proof of concept and showed exactly the same thing happens with K audit. So I don't quite know what statement they were trying to make. I mean, I don't want to be rude about them, but they actually patched their kernel that they were doing the research on to disable the verifier's checks in order to get their code to run so that they could do their research. Whereas everybody else has to learn to write better quality BPF code or edit the assembler, by hand, or insert inline assembler in their C code or whatever else, right? But they I would say cheated in order to.
It's an interesting trick, though, or a hack. I think it's a good one.
Exactly. I mean, if you could live patch the kernel, then you could live patch that out in order to get your code to run. But
yeah, I don't think we're quite at the stage where we can use BPF to modify the BPF verifier. Is that true?
If you're on a vulnerable kernel and you were to use some of the other attacks that were far more interesting on BPF that happened in the last couple of years, then there was an off by one attack on the verifier where the verifier thinks a variable is 0 when it's actually 1. And what you can then do is like if statements based around that, and go down code paths that the verifier will ignore because it thinks you can never get to those code paths. And then you can use that same thing to add onto a memory location. So you could have like a map where it's a certain size, it's 64K in size, and the verifier will let you access any byte within that 64K, but no more. Well, of course, if you've got a pointer right at the end of it and you add a variable that the verifier knows is 0, it's going to go, well, that's fine because you're still at the end of the map. But actually, it's 1. You've now got a pointer 1 byte beyond the end of a map. So if you do that a lot of times, you can have a pointer that's a long way from BPF-owned memory. And you can be right in the kernel and you can be right into it. So, so you could use those bugs. I read 2 fantastic write-ups. The second one built on the first one. I'll look them up and put them in the show notes. Because this is the thing, just understanding the research and what they did in order to make that happen, to trick the verifier, is really, really fantastic, really interesting. So it's worth a read, even if you are never going to use it or never going to do anything with it. And of course, the interesting thing with it is you can fix the verifier gets fixed, because that's public research. But then is it being backported to previous kernels? And if it is being backported, are distributions then taken on the backports and backporting it into their previous kernels? And even if they're doing that, are customers running, say, 4.19, rebooting that machine with an updated kernel? Possibly not. So those kind of bugs will lay around and will be. I mean, it's not a reason not to use. Because we had an internal conversation at the time of like, is this something where we would advise customers to not use BPF? And it's like, well, they can't. Like, the BPF is in the kernel, so any program that comes along that wants to use BPF can therefore exploit this particular bug if the kernel's got that vulnerability. So if they want to reboot their, upgrade their kernel and reboot, then they can, and then the vulnerability goes away. But if they want to stay on, an unpatched kernel, there's us writing a program using BPF. We're not adding to the problem. The problem, already exists.
Yeah, and BPF is not the only part of the kernel, and the kernel can have vulnerabilities.
Exactly.
So people should not be running with unpatched kernels. Is really the bottom line of it.
I know, but everyone does.
If we can come back to, because we had a question from YMO about those helpers that you were talking about earlier, and what license they're under. So these are the kind of header file.
Yes. So the way all of the BPF code in Sysmon is GPL licensed, GPL2, because it relies on GPL helpers. Typically, BPF probe read, for example, is a GPL helper, I believe. So because of that, they have to be GPL. The sysinternals eBPF library itself, the shared object, is LGPL 2.1, because that can load code into the kernel that's GPL. But it's a nicer license, and so then Sysmon itself can be MIT license for the userland code and link to that shared library, but the Sysmon BPF code itself is GPL2. I hope that answers the question. It says thank you. So I think that might. It's one of those things. I'm not a lawyer, but yes. Microsoft have lawyers, and so I had a really great conversation with a really experienced open source lawyer, where I had to explain how BPF worked in order to help him get his head around how this licensing should work, and it was really good. We spent a long time talking about it, drawing pictures, explaining things, which helped me understand. When you can explain something, that's when you truly understand something, right?
Absolutely.
So that was great. And then a few months later, we were coming around to release, I think, and I was asked to go back and just check with the lawyers again. We needed things like disclaimers, boilerplate text to go on things like that, which the lawyers would generate for us. And so, and get their approval for releasing software and things like that. Microsoft obviously have a lot of processes. So I ended up with the same lawyer, and he was like, yes. He said, when you spoke to me about BPF, I'd never heard of it, and you explained it all, and it was this mythical technology that I'd never seen and I was never going to see, and you had this niche problem to solve. Since then, he says, you've probably heard of Windows eBPF. Well, I waded into that discussion as an expert.
That's wonderful. So that's the eBPF for Windows project that we saw an article from the News Stack about that just this week. So were you
exactly
at all to the technical side of that project while you were there?
So they approached Mark Rusunovich, as the owner of Sysinternals, early days, well before the foundation and things like that, and so Mark got me involved with them in a meeting where we talked about Sysinternals. Now, as it turns out, at the time they were very network heavy on the things they'd implemented, so it was more about more the Cilium kind of end of the world. So it could be like load balancing, it could be packet routing, firewalling, IDS, that sort of stuff, but very packety. And they wanted, or they were interested in something like Sysmon, which they knew was coming out as eBPF. I used to run a BPF mailing list inside Microsoft. So anything and everything BPF kind of went through that mailing list, and there's quite a lot of people on the distribution. So they knew of our progress, they knew what we were doing. So they were like, well, could the Windows version use BPF as well? Which is a fair question. But the problem there is that the Windows, a lot of the sysinternals tools, part of the reason why they're so fantastic is because they use features of Windows that aren't necessarily documented. And by not being necessarily documented, they're not official APIs, and therefore they could change any day, any patch. Things could change. And if these tools were to use BPF to collect their information, then they need BPF helpers to provide access to those APIs. And that would mean locking down those APIs in order to provide a BPF helper to the front end of them. And that's not something that is probably going to happen. Or Microsoft would need to have a much bigger conversation internally about Windows development and APIs before that was going to happen. So we were kind of like, well, if you're like the tools at sysinternals used a lot of API calls, right? And if one of those isn't available, then your tool can't use BPF, because there's one thing you can't do. It's like, well, then you're going to put in a kernel module, a kernel driver for that bit. And the moment you put in a driver, you're like, well, we've already got a driver, that does all of this. Why remind us again while we're moving to BPF? So
right.
So I don't think it's going to happen soon. But some of the other tools in sysinternals only use documented APIs, and therefore maybe akin. So anyway, we had quite interesting conversations with Dave Taylor and the team to explore those kind of things. I imagine it will go forward in leaps and bounds and become a fantastic platform on which to build. I mean, just the things I've seen this week, it's starting to look really exciting in that space. So yeah, I'm really happy for them, but I wasn't involved.
Yeah, no, it's amazing to see something that sort of originally seemed so tied into the inherent working of Linux, actually being able to translate those concepts into other operating systems. I think that builds a really powerful platform.
Oh, it is. And I think there's still conversations to be had, but if they can build something that is API equivalent and bytecode equivalent, you could literally have portable BPF programs, which would be an astonishing thing. The same code running inside Linux and running inside Windows. I mean, of course, the other thing to bear in mind, and again, I didn't really do a lot with this, the Windows subsystem for Linux, second version, WSL2, runs a Linux, kind of runs a Linux kernel, and you can kind of do BPF type things in that on your Windows desktop. So because I mean, as I say, I didn't really do anything with it, but somebody else in the team was compiling Sysmon, it's compiling my code up on the Windows desktop in WSL, and I was like, wow, well, like, we really don't support how does that work? And he goes, well, I have to recompile the kernel and turn on BPF, but I have. That's incredible. In the future of observability on Windows could be BPF programs running on the Windows side and BPF programs running on the Linux side of the same system, which again is a complicated, crazy world that we live in these days.
Yeah, and then if you could bring that data together in a nice human readable form, and nobody needs to know or care
where it came from,
operating system it came from. I think one thing that Dave Taylor had pointed out to me that made a lot of sense is network packets are they're structured. They have to be interoperable. A TCP packet on a Linux machine looks exactly the same as it does on a Windows machine, and that means there's a lot of commonality in. If you look at a network packet at a certain point in the stack, it's going to look the same regardless of what the operating system is. So from a networking functionality point of view, that idea of interoperable BPF or portable BPF code is pretty interesting.
Absolutely. And again, the more we can move towards portability, the more we move towards reuse, and therefore additional reliability, common bug and troubleshooting. There's a lot of benefits that would come from that.
Yeah. One more question from YMO, who has been on fire today with questions. I'm going to guess this is a little way out, but can you imagine a future where eBPF and core would be supported on WSL2?
So eventually, yeah. I mean, support is obviously a big word with dollar signs attached to it. So I'm glad I don't work for Microsoft in order to misanswer this question. So I don't know if it is supported. I didn't ever run it. A colleague did, but I believe it works. I mean, try it out. Sort of find
if
out.
Somebody tries it out there. Let us know how you get on. That would make a really interesting.
It'd be great for the summit,
article, maybe even an eCHO episode. That would be quite fun. All right, we are getting close to the end of the hour. If you have any late-breaking questions for Kev, type them in quickly now. Kev, any sort of last thoughts that you would like to share with our viewers today?
So the code for Sysmon for Linux and Sysinternal's eBPF and Sysmon Common is all on GitHub. The links are in the show notes. It's pretty well documented. It's as structured as possible. I wrote it as nicely as I could to make it readable and understandable. There's a doc directory in the Sysmon for Linux repository, which have 7, I think, text or markdown files that explain various things about how BPF works, or my understanding of how BPF worked when I was writing Sysmon. I mean, my understanding has improved a lot since I've joined Isovalent.
You could probably go back and contribute some changes.
They said that they were like, presumably you are still going to work on this in your spare time. I said, I don't know if I have any spare time. So and in there they refer to example programs, and so if you are new to writing BPF programs, libbpf based BPF programs and the likes, and you want to see some good well documented examples with explanations of how they work, what they do, then have a look in the Sysmon for Linux doc directory and have a look at some of those examples. So hopefully that will show you some ways of doing things that aren't necessarily entirely based on syscalls as well.
Fantastic. We should check out those examples. So I'm also going to say hi to Rio, who joined us a while ago, and I missed out saying hello, but thank you for joining us. More importantly, thank you so much, Kevin, for your time today and for sharing, the history of Sysmon for Linux and lots of really interesting anecdotes about hacking and writing BPF code. So thank you so much.
No worries.
And everyone else, Duffy will be here next week at the US friendlier later time of day. So we'll be back then, and have a great weekend, everyone. See you soon.
Cheers. Bye-bye.